Variation. So today in this session, we want to discuss variations. It's not very new. We have four types of variations. One is a direct variation. Number two, it is a inverse variations. When the two are combined, they give us number three, which is called joint variation. And then the last one, number four, is a partial variation. In direct variation, we normally say a quantity y varies directly as x. So these are two variables, x and y. Then when we say that a quantity y varies directly as x, it means this is the proportionality sign, proportionality equation, which later we introduce a constant and it becomes y is equals to kx. Introducing a constant, it becomes y is equals to x. In inverse variation, when we say a quantity y varies inversely as x, now the x goes to the denominator. And this one translates to an equation, this is a proportionality equation, which translates to y is equals to k over x. So when there is inverse, it means on the right hand side, the other quantity goes to the denominator. It is inversely related to the other quantity. In joint variation, where you say now we join the two quantities, three quantities, which are, so we say the quantity y varies inversely as the square of x, and the quantity y varies directly as the square of y, and inversely as x. The quantity y varies directly as the square of x and inversely as x. So this statement, that's what it means. Introducing a constant proportionality, we have y is equals to k x squared over x. These are, yes, it is the quantity is x, but it is now varying twice in a way. One is when it is squared, and another one when it is not squared. So we treat them as three quantities because x squared is not x. So this one is now joint variation. In partial variation, we say the quantity y partly varies as x, and partly varies as the square root of x. Introducing a constant of proportionality becomes y is equals to ax plus b root x. Still, we can say a quantity n varies is partly constant and partly varies as x. So it usually means y is equals to k plus ax. Remember, this one was constant. K was constant. The quantity n is partly constant and partly varies as x. Partly constant. When there is a constant, we don't introduce constant of proportionality because already it is a constant. It does not have a variation. So these are the four variations that we are supposed to use to answer questions. So we have this one. This line stands for proportionality. These are the proportionality equations. And these are now the equations connecting with a constant of proportionality K. And when it comes to partial variation, a quantity Y partly varies as X and partly varies as the square root of X. So introducing a constant, we introduce a constant to a variable. We introduce a constant to a variable X, introduce a constant to variable root X. When we say a quantity N is partly constant and it partly varies as X, introducing constant of proportionality, we don't introduce a constant to a constant. We only leave, because K was a constant, we say Y is equals to K. We only introduce a constant of proportionality to X because it is only X that was varying. Very good. Now I want us to try one question. And we go to our manual variations. I think if we have variations somewhere, formula and variations, yes. Let us address a question that is maybe trial paper. Nataka kutafuta yenye iko na 10 marks. Trial paper 2. Trial 2, paper 2, question 21. Let us check whether it has a good equation. Trial 2, paper 2. This is 4. Trial 2, paper 2, question 21. Let us see how it will behave. Yes, it's a good equation. Let us pick this one. Question 21. Good. Ivan, read the question.
P varies directly as the square of Q and inversely as R. Given that P2 when R is equals to 5 and Q is equals to 4, find the equation connecting P, Q, and R. If P is equals to 4.5 and R is equals to 5, find the positive value of Q. If Q increases by 5% and R decreases by 10%, find the percentage change in P.
Good. So this one lies under which variation, Beth? Direct variation, inverse variation, joint variation, partial variation. It lies in which variation?
Joint variation.
Joint variation. We are connecting direct and inverse. So we start by reading literally as it is suggesting. We are told that a quantity P varies directly as the square of Q. So we say P varies directly, so Q as the square of Q, and inversely we say it goes to the denominator as R. So you even get back read and try to relate. P varies directly as the square of Q. P varies directly as the square of Q, and inversely as R. So R should go to the denominator and the Q squared on the numerator. From this one, it translates to, this is a proportionality equation. Now it translates to a translates to an equation. So P is equals to K Q squared over R. This is now the equation, arbitrary equation. This one because it has a K. It is not, so far it is not an equation. It becomes an equation when we are given additional information. So that we work out for the value of K. So we are given at part A Roman 1, given that P is equals to 2. So you substitute P is equals to 2. And when R is 5 and Q is 4, K 4 squared over 5. This one becomes 2 is equals to 16K over 5 times 5 times 5. So 16K is equals to 10. So we work out for the value of K divided by 16 by 16. So K is equals to 5 over 8. Now, once you have worked out for the value of K, you get back to the equation and substitute the value of K. So we know K is 5 over 8. So now equation connecting we are told to find the equation connecting PQR. So the equation connecting PQR is equals to, P is equals to 5 over 8 Q squared over R. That is the equation which is connecting the three variables. So it becomes an equation after you have worked out for the value of K and you substitute it in the equation. Very good. So let's so far anybody has a question? We are together. But Roman 2. If P is equals to 4.5 and R is equals to 5, find the positive value of Q. So we substitute in the equation. In Roman 2, we substitute what we are given the equation of P is equals to 4.5. So 4.5 is equals to 5 over 8 times Q squared, we don't know Q, over R, and R in this case is 5. So we work out 5 and 5 will cancel. So you remain with the 4.5 is equals to Q squared over 8, cross multiply. Q squared is equals to, what is the value of Q? Q squared is 4.8 times 8. 4.5 times 8.
36.
36. So Q is equals to, find the square root both sides. plus or minus 6. So the positive value of Q is 6. Now you must isolate. You must isolate and say, because we are asked to find the positive value, because we know that the square root of a number is plus or minus. Well, now we move to part B. We are asked to find if Q increases by 5% and R decreases by 10%, find percentage change in P. We know that we have the original value of P is equal to K Q squared over R. That is the original form of P. Now, what will it be P after the change? So we introduce the change in Q. Q is increases by 5%. So Q becomes, our new Q becomes 105% of Q. And this one gives us 1.05 Q. Introduce the changes in each and every variable. R decreases by, so R after change decreases by 10%. So it becomes 90% of the original. 100 over R. This one is 0.9 R. So you introduce the changes in the two variables. Now what will it be P after the change, the new P? It will be equals to K into new Q, 1.05 Q. But now this one is squared over the new R, 0.9 R. This one calls for evaluation. Let us now evaluate and see how it will behave. So P after change will be equals to 1.05 squared. $1.1025 K Q squared over 0.9 R. Make sure that the coefficient is just one number. So we divide the 1.1025, we divide it by 0.9. We get 1.225 K Q squared over R. This is now P after the change. I want you to get the steps. The steps we are undertaking, we started by getting the original, what was the original form of P. After the original form of P, introduce the changes. Q has changed by increase of 5%, so it is 105%. R has decreased by 10%, so it is 0.9 R. Introduce the new changes in the equation connecting P. So P1 after change, it is K into bracket Q, but our Q is 1.05 Q, so we square it. So it gives us 1.1025 KQ squared over 0.9 R. And then we get 1.225 KQ squared and then over R. So we have the new form with a coefficient which is very solid. Now it is very easy from now to work out for the change. So percentage change will be in P will be equals to what? So we simply take the coefficients, percentage change in P is equals to P1 minus P over P, then times 100. We don't struggle so much. We take the coefficients of P1 minus the coefficient of the original P divided by the coefficient of the original P, then we multiply by 100. So it is 1.225 minus 1 over 1 times 100. And this one gives us 0.225 times 100. So 22.5%. This is where I want you to have this skill. After expressing P1 and you have made sure that the coefficient is a single number or just a fraction or a decimal, then you take the coefficient of P1 minus the coefficient of P. P was equal to KQ squared over R. We take the coefficient of P, which is 1. Coefficient of this statement, KQ squared over R. We also have here KQ squared over R. But now what is the coefficient of KQ squared over R? For one, it is 1.225, another one is 1. So we take the coefficients, 1.225 minus 1 divided by 1, and then we multiply by 100. So 1.225 minus 1, 0.225 over 1. Then you multiply by 100, you get a percentage change is 22.5. Great. Any question? No question. So we will try another one. So I will give you a few minutes so that you also try. Let us also go to the one that has acha tuone trial trial 6 paper 2 tuone question 24. Trial 6 paper 2. This one no. Maybe the 16. Yes, question 16. I want to give you 2 minutes. You attempt question 16. You ask the question 16. Well, if you are done, raise up your hand. Tunaona sisi wote nani anainua mkono? Beth amefanya. Next. One person is done. Gift is done. Let us compare the two answers. Beth, what is your percentage change?
4%.
Beth has 4%. Gift, what do you have? Okay, let us have a look at the question together. So as you compare your working, three quantities P, Q, and R are such that P varies jointly with Q and the square of R. Find the percentage decrease in P if Q is increased by 50%, R is decreased by 20%. P varies jointly with Q. So we start from that is where the variation of P varies jointly with Q and the square of R. If you have a look at the equation, there is no communication whether it is inverse, whether it is direct. But when there is no mention of direct inverse or direct, that one automatically goes direct. So P varies jointly with Q and the square of R. Q and the square of R. Introduce constant of proportionality. P is equal to K Q R squared. Find the percentage increase. So let us decrease. Let us bring the changes to P. Q is increased by 50%, so it is 150% of Q. This one gives us 1.5 Q. And that is now Q after the change. And R decreased by 20, so R becomes 80% of R. This is 0.8 R. This is R after the change. Once we are done by bringing in the changes, bring in the equation now. P is equals to K, Q, but our Q is 1.5 Q, and then R squared, but our R is 0.8 R, and then squared. Now, bringing in the effect of this, 1.5 times 0.8. This one becomes 1.5 KQ. This one becomes 0.64, then R squared. 1.5 times 0.64. 0.96 KQ R squared. And this is now after the change. So we have the original P, which was KQ R squared. And the P after change, it is 0.96 Q R squared. So what will be now the change? We said we take the coefficients. It is P1 minus P over P times 100. But we take the coefficients. So 0.96 minus 1 over 1 times 100. This one gives us negative 0.404 times 100. And this one gives us 4%. So when it is negative, it means it is a decrease. So P decreases by 4%. That's what we do in formula and variation. I would advocate that you do the other ones, and then we communicate if there is n. Let us see one, and then we call it variation. Anybody who has a question on formula and on variations that you can post to us? Formula, we have one question 13 that lies in formula and variation. Now this one is on formula. It is also very okay if we talk about it. In the process of making changing subject of the formula, I've decided to pick this one because it is a little bit necessary to know that if the letter you are making the subject is on the power, that is, we are making n the subject, and the law relating some two variables k and l was found to be kl power n is equals to c. KL n is equals to c. Make n the subject of the formula. So what we are making the subject is an index. And somewhere you said that if you are making an index, you are expressing n as the subject of the formula, and it is the index. So what is required is that we must introduce logs. That one has no shortcut. We introduce logs, both sides. So you will say log k l power n is equals to log c. Using the laws of logarithms, we are multiplying k and l. So using the law of product, it is log k plus log l power n. This equals to log c. We want to remain with what has n on one side. So we remain with log ln is equals to log c minus log k, because we have taken k log k to the other side, so it becomes a negative. So using the third law of logarithms, that it says log x power n is equals to n log x, we can bring this one to this side, so that we have n log l is equals to log c minus log k. So we want to make n the subject. You divide both sides by log l. So n it is equals to log k, log c minus log k divided by log l. Anybody wants a question? So when the letter you are going to make the subject is the power, we must introduce logarithms, both sides. Well, now, anybody who has a question on evaluation and the formula, before we go to address one area? Of course, I'm going to affix the videos, the instructional videos to you, all under one link, so that you choose what to go through. When you create time, time is created, not time is spared for some work. There is always time for that one thing that you like. So if you like to watch an instructional video on the same, there is always time for that which you like. But we will stop at that level. We go to something else.
Excuse me,
Before
Chair.
I choose my, yes.
Chair, I have a question on formula. Chair, you are told to make H the subject of the formula.
Kidogo tu, so that I get where we can write. Hiyo sasa utanisomea aje mpaka tukuje kujua, tuelewane, tutajaribu. We will try. Sawa. Go ahead.
Q is equals to 1 plus RH over L minus HT. Hivyo tu.
What are you making the subject?
H.
Hivyo.
Yes.
Let's give a consideration to this statement. On the left-hand side, we have one term, because a term is described as an expression under a common denominator. On the right-hand side, we also have one term. Somebody might be tempted to say there are two, but it is one term because it is under common denominator. So when you observe and see that the common denominator, we have only two terms. We have single terms on either side of the equation. So we cross multiply. So if we cross multiply, we have Q into L minus HT is equals to 1 minus RH. So you must have a justification as to why you are cross multiplying. It's not every time. We must have single terms on both sides of the equal signs. Open bracket QL minus QHT is equals to 1 minus RH.
1 plus RH.
RH. We take the quantities with the H on the left-hand side. So we take this one to the left-hand side. It is negative RH, so it becomes RH positive minus QHT is equals to, we take QL to the other side, it becomes a minus. So 1 minus QL. Yes, yeah?
Chapa kwa 1 minus RH, mbona umeweka minus na ni plus?
Ilikuwa plus. Good observation. Through Hugo, it is a plus. So this one becomes negative. Okay, if we do the changes, let me get back. We highlight a few things. Somebody has observed that it was a plus, which I agree. So we have now cross multiplied. Up to that level, we are fine. Opening brackets up to this level. Then we bring all terms with the X, with the H on the left-hand side. So we take R what? Let us do it differently because the other one was okay. Up to here, let me undo. Well, we are here. We have now opened brackets, but we want to remain with what has H on one side. So let's start. Let us take Q on this side. Minus Q, it enda equal positive. So Q HT plus RH is equals to tupeleke hii to this side. We have taken Q to the other side, so 1 should go to this side. So it will be QL minus 1. we are at that level. We want h and it appears twice and it is common. So factorization is justified. So factor out h into q thing plus r is equals to ql minus 1. Are we together? Good.
Yes.
So we want to remain with the h. So divide by qt plus r. So our h is equals to ql minus 1 over qt plus r. Beth, tutafikia hapo.
Yes. Thank
Another person with a question? That one is okay. Let you try other questions. There are so many actually in the formula and variation. We have attempted a few. Let us now do something on logarithmic equations. Logarithmic expressions and equations. And that will mark the end of our sessions. Logarithmic equations and expressions. Logarithmic equations and expressions. For us to work out this one, we need to equip ourselves with the laws of logarithms. Before we solve equations, before we simplify expressions. Our first law, of course, we want to state them directly. The logarithm of xy to the base of a is equals to log x to base a plus log y to base a. So when we multiply numbers, it will expand to this level. Our second law, it is for division, log x divided by y to the base of a. This one becomes log x base a minus log y base a. The law number 3 we want to use, the logarithm of x base a to the power of n is equals to n log x to base a. Others that we can use, number 4, is very, very main, but there are others which we use. When the number, it is the same as the base, the answer is always 1. Number 5, this one used to exist, but it's leading to extinction, but it still can apply in some of the equations. The logarithm of b to the base of a is equals to 1 over the logarithm of b a to the base of a. So when we say 1 over, they will interchange. they will interchange. Others are the ones on to the base to the powers of 10. The powers of 10 says the logarithm of 1 is equals to 0. The logarithm of 10 equals to 1. The logarithm of 100 is equals to 2. When the base is not indicated, that base is 10. So we say log b is the same as log b to base 10. When the base is not indicated, literally that one is to the base of 10. This is the highlight of the laws of logarithms. So every time we are going to do expressions, we simplify, we are going to solve equations, we must justify why we are making whichever move. Any law that I have forgotten and that you know? Now I want us to go to a question.
Sure.
Yes.
Hapo for the fifth law,
Mm-hmm.
when you are reciprocating hapo 1 over log, inachange hadi base inapanda juu.
Is equals to 1 over
1 over log inachange hapo.
hapo ina change. Kidogo tu, kidogo. Mm-hmm. Hello, hello.
Yeah.
Yes, who was talking before I left?
Acha nilikuwa nauliza
Yes.
the fifth law,
Mm-hmm.
wakati the denominator ina change.
Okay, let me explain it. This law, I said it used to be there. It appears in some of the equations, but it is under maybe kind of reciprocal law. So when we have, we interpret this statement as this is our number, and A is the base. If we reciprocate, so we say 1 over. So whatever that was the number becomes the base, and the one that was the base becomes what? The number. We are going to have some questions that we are told to simplify the logarithm of 2, 3 to base A, plus the logarithm of 2 to 3, the base of 3. How can we simplify this expression? If you take note, here the base is 2, here the number is 2. Upper the number is 2, and here the base is 3. So they are interchanging. So now for us to survive and simplify this thing, we must bring this law, where we want to say the logarithm of 3 to the base of 2 plus yes. Susan.
Yes.
Yes, I'm back. So I'm trying to say that this law can also work even nowadays. When you find that the expression you have, the base and the number are interchanged. So we want to say logarithm of 2 to 3, but now 1 over. So that now we can proceed from there. Otherwise, you cannot simplify. So if it was an equation equated to 1, now we can proceed. So when we encounter a situation where we are solving an equation, the base and the number are interchanging in some terms. So we use this law number 5, though it is not very, very common nowadays, but we cannot ignore it exists. All right, and now we can address a question, Susan. Maybe if it comes along the way, we can still address it.
Yes.
Test paper trial 8, paper 1, question 11. This question is in paper 2. Let us go to paper 2. Trial 2, paper 2, question 7. Trial 2, paper 2, question Trial 2, paper 2, question 7. Yo. Trial 2, paper 2, question 7. Find the value of x given that the logarithm base 2x squared minus 2 minus log base 2 half x plus 5 minus 1 equals to 0. We must bring in the laws of logarithms by all means. Whatever you see must be related to a certain law. Let's address this one, then I give you next question to attend to before we work out. Let's make observation. The log base 2, log base 2. There is one term that doesn't have a log. So let us take this one to the other side. So we have log base 2 x squared minus 2 minus log base 2 half x plus 5 is equals to, we take 1 to the other side, and we want every term to have a log base 2. So we need to introduce log base 2 to this one. So this is 1 log 2, 2. This one is bring in the law number 4. Law number 4, it was saying log A equals to 1. So where there is 1, we can comfortably substitute it with log, but we must maintain the base. The base was 2. So the base also here must be 2. So the number also must be 2 for us to get 1. And we have maintained this 1 because not a must to be 1. So then ensure that the coefficient of every term is 1. Now we can factor out log base 2. On this side, we can factor out log base 2. So log base 2 into x squared minus 2. Because of this sign negative, it means the two numbers were divided. So our number is x squared minus 2, x squared minus 2. So over a half x plus 5. Because of the negative, it means the numbers were divided using the row number 2. The row number 2, which says log a x over y. So the two numbers, now our x is x squared minus 2, and our y is a half x plus 5, x squared minus 2. So we divide equals to log base 2, 2. We drop logs because we are talking about the same thing on both sides. We can easily work with numbers alone. Because their logarithms are equal, the numbers also should be equal. So we drop logarithms, we remain with x squared minus 2 over a half x plus 5 is equals to 2. Cross multiply x squared minus 2, it is equals to 2 into x half x plus 5. Open brackets, x squared minus 2, it is equals to x half x times this one, x plus 10. Bringing in the like terms together and everything to this side, so we have a quadratic equation, x squared minus x minus 12 is equals to 0. Sum -1, product -12. Two numbers, -4 and 3. So we have x squared minus 4x plus 3x minus 12 equals to 0. And that's our equation. Factor out what is common. X is common. X minus 4 plus 3. X minus 4 is equals to 0. X plus 3 and x minus 4. So is equals to 0. So the value of x plus 3 equals to 0, or x minus 4 equals to 0. So x is equals to -3, or x is equals to 4. And you have worked out in that flow. Now you see, mathematics calls for many concepts in at a go. Like this question has moved us from logarithms, we are going to quadratic. So we have to work hard and know a variety of things, a variety of concepts. And use whatever that you know. We are not blank. So we know a variety of things that will help us to answer questions. Any question here before I give you one to attempt? I want you to attempt one on logarithmic expressions and equations. Let's move to trial 3, question 9. Trial 3, question 9. Trial 3, question 9. Evaluate the expression without using mathematical tables or calculator. We are using the laws of logarithm. I give you a few minutes so that you try. Saying how excited she is for their date on Sunday. Even without permission, Yutoki decides to disobey his mother and goes to the girl. Very nervous, he asks her what she wants to do or where she wants to go. But unexpectedly, Yutoki suggests that they go to the shop. Yutoki is Satomi comes in with 2 glasses of ice cream, and this makes him feel more safe. The two are sitting on the bed in an uncomfortable silence. Suddenly, Satomi takes off her clothes and throws herself on top of him. She asks if he doesn't like her. Brother Toki replies that it's not that. He just wants her to get dressed. Satomi says that she is in love with him and prepares to kiss him. Brother Toki pushes her to the side of the bed, explaining. This is Keita. He's just an ordinary student. Early in the morning, his older sister Aiken rushed to work, telling him to eat breakfast properly and not to be late for school. He later heard that his sister had missed her train. After going outside for some fresh air, he learned from the neighbor suggesting he buy a car. Although feeling sympathetic, the neighbor hoped Keita would occasionally come over for meals. He just nodded and promised to visit another time. Keita actually found it troublesome to be a nice person, believing that maintaining too many relationships would create obstacles and affect his own life. He then met his classmate Risa, who was happy that Keita was also running late because she didn't want to be scolded alone. Risa mentioned she had won. Ensure you buy user-friendly products from authorized retailers. To find an authorized therapy retailer, go on to genuine demo. Jim Kamijo is just your average high school kid who's always down on his luck. He's pretty chill about his unfortunate life and is willing to roll with it. On the night of July 19th in Academy City, All right. Answers to trickle in. What is the first step? We must use the laws of logarithms. Those who have tried, your expression simplifies to what? If you have tried, not choosing anybody, but if you have tried and you have something, Mora, what do you have?
10.
It simplifies to 10. Somebody ask 10. If you have 10, raise up your hand. Susan, what do you have?
3.
3. Another person who wants something else? Gift, what do you have? Okay, let's try this together. I want to remain without coefficients. This thing can simplify to prime factors. So we have 3 log base 10. This one is the same as 2 to power 2 plus log base 10. 125, it is 5 squared minus 3 log base 10 2. But I want to have to eliminate these 3 so that I get a coefficient of 1 everywhere. So I would have log 10 2 to power 6 plus log base 10 5 squared minus log 10 2 to power 3. Yes, this 3 will come here. This 3 will come here and multiply. We get a 6. We are adding and subtracting. So using the laws of logarithms, factor out logarithm, log 10, which is common. Factor out log 10. So log 10,
Excuse me, Chuck.
log 10, log base 10 into 2 to power 6 is that 64 times 25. Yes?
Hapa kwa hii yenye hii 125 tumesema ni 5. Mbona tunasema ni 5 power 2 na sio 5 power
Sorry.
3?
It is 5 power 3. Sindio? That one is a good observation. 5 to power 3. So, but now it becomes, this one becomes 64. Sindio? This was 125 and this one becomes 8. Sindio kweli?
Yes.
By 8, 1 by 8, 8. 125 times 8.
1,000.
What do you get?
1,000.
So log base 10 to 1,000. This is the same as log 10 cubed. 3 log 10. Using the laws of logarithms, the law number 4, when the base is the same as the power, it is 3 times 1. And the final answer is 3. Somebody had a 3. You can see everything, whatever navigation you do, it calls for factoring out what is common, changing the powers, the laws, introducing the laws of multiplication, of division, and as such. In the process, you get the final answer. You try another one. Oh, anybody who has not come into terms on how this thing has behaved? Well, we go to the next equation. You'll still attempt before we work out. Trial 4, question, trial 3, question 9. And you tumefanya. No, trial 4. Trial 4, question 4. I give you 3 minutes. Try. Those words made Conway scream at the man, saying that Rain was her hot match, but the man laughed in his face, thinking that there was no chance a weak person like him could tame the rarest ultimate species. But Conway told him that Rain was stronger than he could ever be. So the man challenged Rain to an arm wrestle. Realizing that refusing this match would allow the man to chase against Conway, Rain decided to accept his deal and grabbed his hand, determined to save Conway from being in any danger. As soon as the man announced the beginning of the match, Rain smashed his glorious hand between his. Okay, by now you should be done. Okay, what's the value of x? No mukono tupe value ya x. Irene, what do you have?
I found the value of x as 10.
Irene, x is equals to 10. Irene, what do you have?
5.
5. I can see somebody, Nancy Kamau. What do you have?
5.
What do you have? 5?
Yes.
Debbie, what do you have?
I found the value of x as 35.
That's 5. We have a variety of them. So we'll try. At least people have seen the end. But let us see the easiest way that we can approach this. And ensure that the coefficient of every term is 1. So we have log x plus 11 minus log 3 power 2 is equals to log 9 minus x. That the coefficient of log should be 1. Then this one looks like we can use the second law, the law of division. So we say log into x plus 11 over 9 is equals to log 9 minus x. If we drop logarithms, we have x plus 11 over 9 is equals to 9 minus x. These are two terms on both sides, one on either side of the equal sign. So we can cross multiply. So x plus 11 is equals to 81 minus 9x. This one to this side becomes then x. 11 to the other side becomes 100, 90. 92, I mean. We subtract 70, becomes 70. 81 minus 11, 70. Over 10 over 10. X is equals to 7. I think, if I'm not wrong, X is leading to yeah, to 7. Irene, ulikuwa na gani? Have you seen where you maybe you went wrong?
Yes. Yes.
What's a question? What's a question on this? Well, we tried the last one. Our next one is trial 5, question 7. If you do many of them, they will start repeating each other. It will be a repetition of concepts. Like this one is not very far from what we have worked out. But let me see the responses. Question 7. I want you to work out and get me the response.
is Chris strong opponent this entire time, so she offered to take them both on together. However, Conade reminded him that she was also an alternate species, and as soon as the match began, she rushed towards Rain with all on her speed, but he narrowly blocked her blow. This stressed her, but most adventures had already been won by Iris, so she went on to
Okay, let's move on. We get responses. Susan, your hand is up. What's your answer?
12.
Debbie, your answer?
12.
12. The two are in agreement. Yes, let me hope that it is close to answer. Ikuje huku. So it is log 5x plus 75 minus log 3 squared log 2x minus 9. Factor out log 5x plus 75 over 9 is equals to log 2x minus 9. Drop logs 5x plus 75 over 9 is equals to 2x minus 9. Cross multiply 5x plus 75 is equals to 18x minus 81. 75. This one to this side is 13 minus 13x is equals to 81 plus 75, 156. 156 divided by 13, 12. So the answer is 12. So that's what we do. Now, from your end, anybody who has a question on logarithmic expressions and equations, that's what we do, commonly do. Anybody with a question? Mm-hmm.